What is going on, guys? Welcome to a new short series in the differential equation section of Lemon's Math. This series is called the cheat sheet, and what it essentially is a cheat sheet for you guys to create to help you out in any PDE and probably any ODE exams that you might have and they allow a cheat sheet. This will be containing a lot of useful information, and in this series I'll be deriving and explaining where this comes from. So at the end I will be having probably a page full of everything all condensed that gives you the conditions and the answers right away. But in this series I'll be going through the whole pretty much like derivation or the work to get to the answer, so that way you can understand it and then just kind of like skip through it when you feel comfortable just doing it. So in this one I'm gonna show you how to solve a ODE in like the most simplest way possible. It is so crazy how fast you can solve this. So we're given an ODE in the form of y double prime plus by prime plus cy is equal to 0, and the only condition is a must not equal to 0. So a could be 1, it could be any number as long as it's not 0. And so what we're gonna do is we're gonna do pretty much like the quadratic equation type of thing. And so what we're gonna do is we're gonna find the the determinant. And so if you remember back in algebra, the determinant is usually solved by finding b squared minus 4ac. And so once we solve that, we have four cases. We have the case where we have our determinant being less than 0, so that means this is negative. We have the case where d is exactly 0, and then the case where d is greater than 0 or positive. And this will give us different solutions, and our constants, or our alpha and beta and gammas, those will also vary depending on what our determinant is. So for the negative case, we are going to get the solution e raised to the alpha x multiplied by sine times beta x. And in our second solution will be the same thing. The only difference, instead of sine, it will be cosine. And to find our alpha and beta, our alpha will be consistent throughout the way, all three cases. So our alpha will just pretty much be negative b all over 2a. So that is the case for every single determinant situation. Our beta, however, this would be the square root of negative d over 2a. And because our solution does not contain a gamma, there is no case for gamma. So for our d is equal to 0 case, we're going to get our solutions to be equal to e to the alpha x, and then our second one would be x times e to the alpha x. Again, our alpha is negative b over 2a. There is no b in this situation, and again, there is no gamma in this situation. Our last case, where d is positive, we'll have e raised to the alpha plus gamma times x. Or another way to write this is e to the alpha of x times hyperbolic cosine gamma of x. And then our second solution will be e raised to the alpha minus gamma all multiplied by x, or e to the alpha x times hyperbolic sine gamma of x. And we know what our alpha is. there's no beta in this situation, so our beta is non-existent, but our gamma is going to be similar to our beta. The only difference, instead of the negative, it will just be the square root of d all divided by 2a. And that's pretty much it. This simple table will solve your ODEs so much quicker, and I'm about to show you like in a couple of examples. So let's jump straight into those right now. So these examples, it's only 3 of them, and they're going to be for the different scenarios or situations on solving these equations. So for the first one, again, is going to be our A, our B, and our C. We know our A here is equal to 1, our B is equal to 4, and our C is equal to 5. So to find our determinant, we just simply plug and chug. So we have 4 squared minus 4 times 5 times 1. So this will be 16 minus 20, and that is equal to negative 4. And we all know that this is less than 0. So this is going to be our first case. And so what we do now is we find our alpha. So our alpha, we know it's negative b over 2a. So b is 4, so it'll be negative 4 over 2 times 1. So it'll be negative 4 over 2, or just negative 2. And then because it's the first case, our beta will be equal to the square root of negative d. So it should be the square root of 4 over 2, since a is just 1. And so that'll just give us 2 over 2, or just 1. And so our solution, we can write it as a sum of both of them. So our solution, our our u of x is going to be equal to c1 multiplied by e raised to the negative 2x sine of x plus c2 times e to the negative 2x multiplied by cosine of x. And so if you know the other way or other methods to solve it, you can verify it and you'll get the same exact answer. So let's move on to the second one. The second one is the same thing. The a and b's are the same. The only difference are c is equal to 4. And so this will give us 4 squared minus 4 times 4 times 1. And that would just be 0. And so again, our alpha is negative b over 2a, so that would just still give us negative 2. And this will just be our second case. And so our second case will just be u of x is going to be equal to c1 times e to the negative 2x plus c2 times x e to the negative 2x. Again, if you can verify this using any methods that you know, you're going to get the same answer. And our last example is, again, the same thing. A and b are the same. The only difference is c is equal to 3. So our determinant will be equal to 16 minus 12, or 4. So this will be case 3. So our alpha, as always, is negative 2. Our gamma is going to be root 4 over 2, which is just 1. And so our solution will be c1 times e to the, because it's alpha plus gamma, it will be negative 1, or negative 2 plus 1. So it'll be negative 1, or negative x, plus c2 e to the negative 2 minus 1, be negative 3x, and that would be your solution. Or if you want to use hyperbolic trig, it would be c1 times e to the negative 2x multiplied by hyperbolic cosine of x plus c2 e to the negative 2x multiplied by hyperbolic sine of x. These two are valid answers. And again, if you want to go ahead and check them yourself using the methods you've been doing, you will get the same exact answer. And this is the first of many videos to simplify your life. It was really eye-opening for me when I learned this, and so I look forward to doing another video for this, and the next video will be more on the methods where you use the Cauchy-Euler method. So that one has a table in itself, and that one's such a time saver. But other than that, I'll see you guys in the next video, and enjoy this new cheat sheet series.